It has been a long day of grading your guys' tests. Ugh. It is currently 8 o'clock and I started doing schoolwork today at noon, just so y'all know. And it's a Saturday. And I have no life, so that's okay. We're talking about direct variation today. It's a special type of linear relationship, and I know you're all so excited, and it can be written in the form of y equals kx. K is a constant, and y is not cx is one thing we'll never know. But anyway, we use y equals kx, and that's fun. So anyway, we are going to be identifying direct variations from equations, which, as you can also tell by the enthusiasm in my voice, is super duper fun. So on A, oh, there we go, we have y equals 4x. Now on this one is already written in the form of y equals kx. So if we put y equals kx underneath it, we can see that the constant of variation, or our k, equals 4. So if they're already written in that form, you don't have to do anything. So that's, good part of life. B is negative 3x plus 5y equals 0. So we have to put it in this form of y equals kx before we can find out what kx equals, which means we have to solve for y. Which means we need to get the 3x to the other side, and we get it to the other side by adding, and these cancel. And then we have 5y equals 3x. 5 cannot be there, so we have to divide by 5. And we have y equals 3/5 x. Now this is in y equals kx form, so our constant of variation, or our k, equals 3/5. C. Let's not use yellow. You guys don't like yellow. 2x plus y equals 10. So we have to get it in y equals kx form first. And remember, we have to solve for y, so we have to move this to the other side by subtracting. And we get y equals negative 2x plus 10. And most would be like, oh, well, k is negative 2. But anyways, since you have this term here, there is no constant of variation because it cannot be written in the form of y equals kx. So this does not represent direct variation. Okay. What happens if you solve y equals kx for x? Let's look at this. What happens if you have y equals kx and we're like, we're going to solve for k? Because that's what I meant to say earlier. Well, if we solve for k, we have to divide both sides by x, which is like that literal equation stuff that you all didn't like, and we get y over x equals k. So your constant, or your direct variation, is equal to y over x. Okay? So we're going to use that when they give us the form of a table and they're telling us to find the direct variation. So if they're like, hey, here's x and here's y, and we have 1, 3, and 5, and we have 6, 18, and 30, and we want to find what the direct variation is, see if there is a direct variation. So we want to find out the constant to see if each relationship is a direct variation. So remember, we said that k equaled y over x. So we take 6 over 1, and we get 6. 18 over 3, and we get 6. And 30 over 5, and we get 6. Since each ordered pair is 6, we can write this out as y equals 6x. Whenever you multiply the x by 6, you get y. 1 times 6 is 6, 3 times 6 is 18, 5 times 6 is 30. So our k equals 6. Okay? So, it's an example of direct variation because y over x is the same for each ordered pair. Bada bing, bada boom. Okay, so let's look at another one. Because you know how I am, I like to just do math on the weekends. It's my pride and joy. 2, 0, and 4. And we are looking and we're saying k equals y over x. Okay, so we go negative 2 over 2 equals negative 1. We got 0 over 4 equals 0. And we got 4 over 8 equals 1/2. Now, this is not a direct variation because these three do not equal the same thing. So not an example of direct variation. Okay, so next, if you ever follow along in your book, we're on page 262. The value of y varies directly with x, and y equals x, y equals 6. So anyways, y varies directly with x. And we have y equals 6 and x equals 12. So what we want to do is we want to find the value of k. And then we're going to write an equation. All right? And have fun and all that. So we're going to find value of k. So the first thing we do is we set y equals kx, and for y we put 6, and in for x we put 12. Then we got to get the 12 away, so we divide by 12. 6 over 12 reduces to 1/2, so k equals 1/2. Okay? So our direct variation is y equals 1/2 x. Alright? So, then the next thing it says to do is find y when x equals 27. Seems pretty easy. So we use this equation here, y equals 1/2 x, and we put 27 in for x, and when we multiply or divide that, you get 13.5. Okay? So next we're going to use a proportion. Actually, we're not going to use a proportion because this is way, way simpler. And life being simple is what I would like to, do for you. So, we're only going to learn one way. So, you find out what k equals. And when you have what k equals, you put it in this form. And then whatever it says x equals, you put back into here and you solve. The proportion one I don't care about. Okay, so a 3-toed sloth is an extremely slow animal. Are those like on Ice Age? On the ground, it travels at a speed of about 6 feet per minute. So about how fast I travel. So 6 feet per minute. Write a direct variation equation for the distance y a sloth will travel in x minutes. Distance y in x minutes. So that's what we're doing. Sounds easy enough. So we have distance y. So we're going to write that as y equals 6 feet per minute. So that's our direct variation equation. Okay. And then we got to just choose values. So we're trying to figure out how far this sloth is traveling. So this is our equation we're going to use, and we're going to set up an XY table, and we're going to see how far he travels in 0 minutes, 1 minute, and 2 minutes. Well, if he hasn't traveled any minutes, he's not getting anywhere. If he's traveled for 1 minute, we put a 1 in here, and 1 times 6 is 6. And if he's traveled for 2 minutes, we put a 2 in there, and 6 times 2 is 12. Okay? So these are our ordered pairs, right? And then we're going to graph because it tells us to. So all of those are positive points, so we're only looking at the first quadrant. And we got 1, 2, 3, 4. We're going to go up by 6s on this side because you know it's going to go up by 6s, and I don't feel like writing more. So 6, 12, 18, 24, and we got 1, 2, 3, 4, and at 0, 0, and 1, 6, and 2, 12, and we're going to draw a line, and it just keeps going that way. So every minute you add 6, and we're done.